Hello students, my name is Chandrasekhar Soni. In the previous class, we have discussed about the signals and classification of signals. In this class, today we will discuss about periodicity of the signal, how to check the periodicity of the signal. So let us see by the example how we can check the periodicity of any signal. So we have the example prove that the sine wave is periodic signal. So this is the question, or this is the wave which we have to prove that is periodic or not. So the graphically represented sine wave is x of t, and it is given by x of t is equals to a sine omega 0 t. This is the mathematical expression of sine wave. Amplitude of this wave is a. So how to check the periodicity of this signal? We know that the condition of periodicity is given by x of t is equals to x of t plus t0. Equation number second. Here, what is t0? T0 is the time period from which any signal repeats itself. We can see from the diagram. This is the time period t0. That is equals to 1 upon f0. So t0 is what? It is the time period from which any signal will repeat itself. Okay. So this is the equation number second. So let us find the expression for x of t plus t0. X of t plus t0. Okay. Replace t by t plus t0 in equation number first. We have a sine omega 0 t plus t0, a sine omega 0 t plus omega 0 t0, x of t plus t0. Okay, see this equation. The equation is like sine a plus b, we can see. So it is equals to sine a cos b plus cos a sine. So this is the formula. So apply this formula in this equation. We can give the equation number 3. Okay, apply this formula in this equation. We will have x of t plus t0 is equals to a sine omega 0 t cos omega 0 t0 plus cos omega 0 t sine omega 0 t0. Okay, we know that omega 0 is equals to 2 pi f0 and t0 is equals to 1 upon f0. So we have omega 0 t0 is equals to 2 pi f0 into 1 upon f0, that is 2 pi. So we have omega 0 t0 is equals to 2 pi. Okay. Substitute this value in equation number 4. We have x of t plus t0 is equals to a sin omega 0 t cos omega 0 t0 is replaced by 2 pi. It is 2 pi cos 2 pi plus cos omega 0 t sin 2 pi. Here cos 2 pi is 1 and sin 2 pi is 0. We have a sin omega 0 t. Here x of t plus t0. So x of t plus t0 is equals to a sin omega 0 t, that is equals to x of t. So what we have, x of t plus t0 is equals to x of t. So this is the condition of periodicity. Okay, so it is clear from this equation that the sine wave is periodicity. Now take another example of the periodicity, whether the signal is periodic or not. So let us see. Prove that the exponential signal is non-periodic. Okay, we have to check the periodicity of the exponential signal. First, we will see the graphical representation of the exponential signal x of t. This is the e to the power minus of alpha t. The mathematical expression of exponential signal is represented as x of t is equals to e to the power minus of alpha t. This is equation first. Okay, we know that condition for periodicity is x of t is equals to x of t plus t0. What is t0? T0 is the time period from which the signal will repeats itself. Okay, this is equation number second. Okay. Now let us find expression for t plus t0. It will be x of t plus t0. Replace t by t plus t0 in equation first. We have e to the power minus of alpha t plus t0. Okay, is equals to e to the power minus of alpha. Separate this to alpha t, e to the power minus of alpha t0. Okay, we can divide in the two parts. Okay, so we know that this is the period of repetition. Exponential signal does not repeat itself after the period t0. So here we can have t0 is equals to infinite. So we can consider this time period as a infinite. So here we can write e to the power minus alpha t dot e to the power minus infinite, because t0 is infinite. So e to the power minus alpha t dot e to the power minus infinite will become 0. So the whole function will be 0. Here x of t plus t0 is equals to 0 and x of t plus t0 is not equals to x of t. So this is the condition for non-periodicity. So it is clear from this equation number 3, it is clear from this equation that the exponential signal is not periodic signal.